Okay, guys, welcome back. So we're still talking about learning curve and how we go about it. What's right slow, for example? How does it play here, and how does it make sense? Okay, and we're saying that the right slow emphasizes on the fact that the cumulative output must be doubling. That what's on top is half of what goes next, or the next one is a double of what's up. Okay, like in this scenario, I've already shown you that you look at one, what doubles one is 2, so that must be in line. What will double 2 is 4, that must be in line, not 3. So that's why you skip the 3. What doubles 4 must be an 8. Okay, what doubles 8, and it goes on and on. That's on the side of the output. Saying in the same spirit, your average time, or what you call the cumulative time per unit, should fall, and as it falls, it must fall at the same rate. So we're going to determine and see. So I'm still here trying to show you how we get the cumulative time first, because for you to get the cumulative time taken per unit, you need cumulative time taken. So, and it's given by, for the first item, of course, doesn't have the previous cumulative time, otherwise it's 0. So we normally go with its time taken, okay, which is a 10. And then we say that for the second double, which is a 2, it will be the previous cumulative, which is in this case is 10 plus its current time taken, which is 8. For the next period, we have a 3 in this case, but cumulative would be the 18 plus the previous, which is 7.3. Okay, then for the 4, it will be this plus this. Okay. Now to get the average time, I said it's given by the cumulative time taken, which was what you computed earlier, divide by the number of units. It's per unit, divide by the number of units. So you come and look for cumulative output and divide. Okay, so for the second period, or the second row, it is the 18 cumulative time taken, divided by 2, which is the cumulative output. Okay, then for period 3, or the row 3, it's the 25 divided by the 3. Then for the fourth, it will be this divided by the 4. This is what you have. So from our law, we are saying that our average time, or cumulative time taken per unit, is actually falling. When you see 10, it's falling to 9, then from 9 to 8.4, from 8.4 to 8.1. Okay, so at what rate? The rate is given by, even from the question itself, it is saying that, not the question, but the law. It says that if I just take it to the law. Was I sharing the worksheet all along? I hope so. If you go to the law says that cumulative output will double. That one you have seen. The cumulative average time per unit falls to a fixed percentage of the previous average time. The point is previous average time. So if I take you now to how we compute those, therefore, we're saying that for this one, we won't compute because they don't have a previous time. Otherwise, you divide by 0. But for the 9, or for the second row, it is this average time divided by the previous. This previous is 10 times 100%. If you express this as a percentage, you get 90%. Okay, but it's important that the current one doubles the previous one. Okay, so that's why for the 3, for example, we should not consider it, because for 3 does not double 2. So it's not in our line. It's not as the law dictates.
Andrew.
When you go to 4, yes, Ronald.
Andrew. Pardon on how you get the 90%.
Okay. So the 90% I've said is coming from the law that you need to know the average cumulative time. And we're saying it is at a fixed rate of the previous average time. So I'm saying that the 9, its previous is the 10. So the 90 is given by the 9 divided by the previous, which is 10, times 100%. Then you get the 90%. Okay, let's see another example or the next item. We say that for the item 3, we are not going to use it because 3 doesn't double what is on its top or what's on top of it. But when you go to 4, which doubles 2, you're saying that its cumulative average time or its cumulative time taken per unit is falling. Indeed, it fell from 9 to 8.1, okay, at the fixed rate. So when you get this still in percentages, you still have 90%. Okay, 81 is falling from 9, not 8.4, because 8.4 is not following the pattern. It is falling from 9. So it is 8.1 divided by the previous, and the previous is 9 times 100%, which gives you 90%. Okay. Now, as you can see, it's 90%, 90%. And that's why they're saying that this rate here keeps falling, but at a fixed rate. So meaning that even for 8, its falling rate must be 90%. Okay. For 16, its falling rate must be 90%. It is fixed. It's the same. So meaning that if I have this information, I can get all this other information, which I'm going to help you get to answer part B of the question, I think. Find is it the 8th, something like that. You can go to the question so that I'm sure I'm answering the question. Compute the total time taken for making the next 4 units to double output to 8th unit of this product. Okay, maybe the what's important to emphasize is they said next 4. So the next 4 is not the entire 8, it's just the addition. So what we do is, if you go to the question, I'm into our workings, what we're sure of is that for us to produce these 4 units, cumulative total, we need 32.4 hours. If the hours. If the minutes, you need 32.4 hours. This is what you need to produce 4 cumulative. Okay, but to take you here, if they wanted to know how much time shall we need to produce the next 2 units from these 2, okay, how much time shall we need to produce the next 2 units from these 2? In other words, how much time shall we take between 4 and 2? Okay, so what you do is you get the cumulative for 4, which is 32.4, and then for 2, which is 18. The difference is the time you're going to take to produce the next 2. I don't know if that makes sense. But let me answer another question that they asked, they wanted. They say that you look for the time taken to produce the next 4 units so that you have the 8th unit. Okay, so that you're at 8, in other words. What you do is you get the cumulative time for 8, and then the difference between the cumulative time for 8 and for 4 will be the time taken to produce the next 4 units. So how do I get that? This is how we go about it. The 90 here, assuming this is our x, yeah, we're saying that is x divided by 8.1 times 100% give me what? Give me 90%. This X here, that's what I've been doing. But for me to get this 90 here, I got 8.1 divided by 9 to get this one. So meaning that for this X to get this 90, here, I'm going to get the X divided by 8.1 because for it it's still in line, it doubles, the 8 doubles 4. So it is X divided by 8.1 times 100%, it should give me this 90. Okay, so therefore you end up with X divided by 8.1 being equal to 0.9 or 90%. So when you cross multiply or you move it on this side, it will be X will be equal to 8.1 times 90%. For those who like, should I say, grammar or shortcuts. So yes, not for me to get this X, I just get the rate times the previous one. Okay, although I would encourage you to do this because you see what's happening. So therefore my X is equal to this times 90%. So it is 7.2 for X for the average time. But to get cumulative, I know that cumulative previously would say that if this is Y, would say that that Y of mine, cumulative, is given by given by, yes, we're saying that Y divided by 8 should give me 7.29. So to get this 8.1, we got the cumulative and divide it by the number of units. That's all. So meaning that in this scenario, this Y here, to get this 7.29, equal to Y and divided it by 8 to plus 7.29. So therefore my Y will equal to what? Multiply Y is equal to 8 times 7.2. That's how I'll end up with this figure here by saying it is the same as this times this. Okay, I hope that is fine. Then now, time taken to produce the first 8 units is given by, still you apply some logic. To get this value here, if this was your M, for example, M, you're saying that I would get the previous cumulative, which is 32. Saying to get my M here, you're saying I'll get the previous 32.4. Then I add an M to give me the cumulative, which is 58 now. Isn't it? That's what I've been doing. So to get this value, you get this previous cumulative plus time taken in year 4 to give you this new cumulative. So meaning if I have M here, I already have a value here. I'm saying it is this previous plus M should give me this 55.3, which ideally you now come and just subtract. So meaning that our M is equal to 58.32 minus 32.4. Okay, so for those who like shortcuts, they will say, I know it is this one minus this. Okay, but I feel like if you just do that, what if you end up adding or something? What if you get confused? So you want to be sure of what is happening. So guys, unless you have any questions, that is how we get those values using tables and applying the law. And I beg to stop here because for the algebraic, I think it is easy. It's just the formula, just apply. I can just stay here just for purpose of time. Algebraic or mathematical, we're saying it is Y is equal to X raised to the power B. You must know the variables that Y refers to what we saw there as average stock cumulative. cumulative time taken per unit. That is your y value. Then the a is the time taken to produce the first unit. Okay. Then x usually is the number of units. Actually, it's cumulative number of units. Cumulative number of units. The first column that you saw. Then b is a formula. You must know it's log r, which r stands for the percentage rate or the learning rate. And divided by log. So once you know these, then you're good to go to apply this formula. So maybe to apply on the table, we're saying that our y here in the formula is actually this y here. This one. This is your y. Whenever you're finding a value here, you're finding y. Then a is usually this one here, this part. This 10,000 here is the a. That's what the values. Okay. It is the a. Now let me apply my what? This format cell, then customize, then you have okay. Okay, this 10a. So the first, as long as you have the first unit, the value that the time you take to make that 1 unit, the first unit is an a. So in our formula, the 10 will be the a. Then x will be of course 1 or 2 or 3 depending. Then b I already told you that just apply this rate here. It's log r over log 2. So guys, thank you for listening to me. I beg to stop here. Kindly talk about when they ask for the next. Okay. So whenever they ask for, I've just answered the one of next. Maybe I should say the first. If they ask for the first 2 units. Let me go with this one. So the first 4 units. First 4 units. If it is cumulative time taken, the answer is this one. If it is average time, this is cumulative time. The answer is that. If it is time taken, the answer is the 7.0. Okay, the first 4. Okay, but if I ask for the next 4, the next 4 units from 1, next 4 units from 1. Okay, that we had a 1 unit of ours. Of course, they don't normally say from 1, but they give you, say, they'll tell you that find the cumulative time for 2 units. Then part B will say find the next, or find the cumulative time to make the next 4. So yes, no, they're coming from the previous question. So here I'm emphasizing it. If it's from 1, if it is from 1 here. Okay, cumulative time is for the next. Remember, this is first, but this is next. For the next, you get the cumulative time. Cumulative time for 1. Okay, which was in this case given as 10,000. And then and then cumulative time for first 4. It should remain the same as this 34. So the next is the difference between the two. This is the big minus small. This value here is what you call the next. Okay, so I hope I've answered all your questions. Okay, I've said that for the first 4 units, you just get the answer. Your y, which will give you, if you're using this formula, for example, your y will give you this, and this must help you to get the accumulated time. That will be the answer. Okay, the first 4, first 5, first 8, first 16. The answer you get is straight. The y times the number of units will give you cumulative time taken. But for the next 4 from the previous one, okay, like I already told you that if they say, if part A was like, if I may sample your question here. Think common question example. No, like this example here. Okay, they gave you the first, say that the first unit of a product is expected to take 100 hours, and an 80% learning curve is known to apply. It said the average time per unit for the first 6 units. I've told you that the answer you get as y is the answer because it's the average time, cumulative time taken per unit. So if you're substituting, you're saying y is equal to a, my a is 100, okay, times x is 16, raise to the power b, which you have computed using the 80%. That will give you the answer. Okay, even this one here for the first 25, same thing. Whereas x, you put 25. Now for part C, the time it takes to make the 20th. Another version would say the next unit after the 19th. Okay, they mean the same thing. Okay, the next unit after the 19th, it is the 20th. Okay, so what do you do? How do you compute that? What you do is you get the cumulative time for 20 units and you get cumulative time for 19 units. The difference will be for that 1 unit of 20. Okay, I hope I've answered you, Davison. Okay. Shakira, about probabilistic budgeting. There's nothing new, or it's not a big deal. The whole thing is, do you know what you call expected values? Let me see if I can see an example here. Do you know what you call expected values? If you know expected values, then you are good to go. Because what happens is they give you percentages trying to reduce the risk of uncertainty. I don't think we made it here. I think we made it. But I can create a scenario. Okay. Probabilistic budgeting. Usually it happens on units of production or on units of sale. They will tell you that maybe at the price 50,000, that they have probabilities and units in sales. At 0.1, for example, they expect to sell maybe 1,000. At 0.5, expect to sell maybe 500. Then at the balance, which is 0.4, they may say they're going to produce maybe 600. Okay, now, if you're finding sales, the number of units that you use to multiply with the selling price is given from these probabilities. You get expected value. And expected value here, in terms of sales, is given by the probability times its corresponding unit plus probability times its corresponding unit plus the probability times its corresponding unit. So here we said the real sale or the real number of units that they sold are 590. The expected value of sales is this one. So therefore, our sales value or our sales revenue, we say it's given by the selling price, which is 50,000, times the expected sales in units, which is 590. So that's how we apply probabilistic budgeting and stuff like that. Shakira, have I answered your question? Or do you have any way you want to misunderstood, then I share? Because probabilistic just tries to minimize risk by putting in consciously what we call probabilities, the chances of something occurring and not occurring. So because of that, we find expected values to end up with now what we think this one here. I think it caters for all risks. If we do well, well and good. If we do badly, well and good. So the 560 is fair to say compared to the 1,000, the 500, and the 600, because that's catered for all the risks. And this becomes now your selling units. So when you're now coming up with a budget, our sales will depend on this unit here. Okay. All right. Guys, I'm not seeing any questions, so I think you cover. Then you can stop here.
Katabazi.
Mm.
Can you help me repeat the 20th unit? Is it 9? You calculate the 19 units then?
Yeah, you complete the first 19. First 19, you get the value. Then first 20, you get the value. The difference is the 20th unit. They're going to tell you what's the next unit after 19. How much time will it take? That's how we get it. Maybe you can,
Thank you.
can try out an example, no problem. Let's try out an example, this one.
Okay.
You're forgetting to mute. Okay, this was the information given. You said that the first unit of a new product is expected to take 100. So in your formula, we're saying in your formula, if it is this is the formula. Okay, we're saying that our A is 100. Okay. Then they say that okay, this is not given. This is not given. Okay, our B we're given the rate as 80%. So you know that my B will be equal to log 0.8. Someone should help me get the figure because I don't have the calculator here. Then log 2. Okay, someone should help me with the value. Do you mind if human my mind okay, someone the value.
But we're not seeing the screen.
What's the value there? When you compute log, open brackets, log 0.8, close brackets, divide by, open brackets, log 2, close brackets. What do you get? Guys, you're taking long. What figure are you getting? Okay, since you're taking too long, assuming you get 0.013. They're saying that now the question wanted the 20th value. Let me just go straight to what they want. 20th value. Now I'm saying 20th value, you first get the time taken for the 19th value. The time taken is that my y will be equal to, if they want the average time, to be equal to a, which is 100, times 19, which is the x, raised to the power negative 0.013. Okay, so therefore my y will be equal to what? Whatever you get, assuming you get 1, 2, 3. Okay, and that is your y. Now this y is for the 19. If they ask for average time, if they want total time taken, so the cumulative, just say the 1, 2, 3, which is the average, 1, 2, 3, times the number of units, they were 19, to give you the value. So the first 20, same thing. You say y is equal to 100 times 20 raised to the power negative 0.0103. Okay, and y will give you maybe 1 to 5. Okay, now meaning that of course if you want total time, or cumulative time taken will automatically be equal to the 125 times the 20. So for the 20th, I have this. For 20th unit or the next units, 20th, is the difference. It is the 125 minus 123. Okay, that is if it's average. But for the total, use the answers that you get from this and this. Okay, so guys, thank you for listening to me again. I want to wish you success tomorrow and have a good night.